Hi guys, today we're going to talk about coordinate proofs, specifically with quadrilaterals. The last video, 8-1, was coordinate proofs with triangles, and today we're moving into four-sided shapes. So first we're going to take a look at this quadrilateral family tree. Essentially what this is saying is that we start with a quadrilateral, a polygon or a shape with four sides, and we can branch off in one of two directions. One going towards trapezoids, and the other one going towards parallelograms. Any property from the top gets carried down to the bottom. So maybe you want to write properties are carried down. So for example, a trapezoid is a quadrilateral, meaning four sides, with only one pair of parallel sides. So we're going to mark parallel by doing these little arrows. But then we move on to an isosceles trapezoid, which has parallel sides, but now it also has congruent legs. The legs are the two sides that are not parallel. Bases are the top and the bottom. But our main focus is going to be on these four shapes over here. You might see trapezoid every now and again, but the four on the right are the real focus shapes for this unit, for this course. Parallelogram has opposite sides parallel, so not only do we have one pair, but we now have two pairs of parallel sides. Remember, properties get carried down, so if we move towards the right at a rectangle, it still has parallel sides, but now it has four congruent right angles. So we're going to put those little right angle boxes in there. I'm going to go back up and then down the left side towards a rhombus. It's a parallelogram, meaning that there are still parallel sides. Oops. Make sure your arrows are facing in the same direction as one another for those opposite sides. But it also has four congruent sides. It's like a tilty square. Now a square is a combination of a rectangle and a rhombus. Opposite sides are parallel. I'm not going to mark that because the more important thing is that there are four congruent sides and then also four right angles. This is where we want our main focus to be again. So you can remember this little family tree by the acronym PRRS. P-R-R-S. Kind of like my little kitty. She purrs. Parallelograms split into rectangle and rhombus, and then rectangle and rhombus come together to make a square. I couldn't resist the cat picture, so here you go. Again, P-R-R-S, purrs, like my little kitty Betsy. Say hi, Betsy. Okay, moving forward. Properties of quadrilaterals. Wow, Betsy's going to stay right there with us. Okay. When concluding type of parallelogram from a table, you must know the basic properties of these figures. Sometimes more properties can be concluded from the table. These are the properties that we'll see in parentheses. So the basic properties are outside the parentheses, and then additional properties are inside the parentheses. So for example, in a parallelogram, the basic property is that opposite sides are parallel. You might also find, though, that opposite sides are congruent. In a rectangle, opposite sides are parallel, and there's a right angle. Tiny space to write the word right. But again, still know that opposite sides are congruent still. A rhombus has four congruent sides, but opposite sides are still parallel. A square has four congruent sides and a right angle, but again, opposite sides still parallel. A trapezoid has one pair of opposite sides that are parallel. In an isosceles trapezoid, same thing, but there are also congruent legs. Flip it over, we still have a little bit more notes to do before we get some practice. So with coordinate proofs, there's quite a few steps that we need to follow. The first being that you should set up the following chart. We did this back in 8-1 video, so if you're struggling with this or you just can't get it today with this video, maybe try checking out the other one. So we set up this chart. We have four sides in each quadrilateral. Remember, it's a polygon with four sides. We have a change x, change y, Pythagorean theorem, and change y over change x. Pythagorean theorem stands for length. and change y over change x stands for slope. We calculate those changes, the change x, change y, by subtraction, which you can see here. Once we have those changes, those become our a and b values for Pythagorean theorem. And then we can use the a and the b values for the slope as well. Once we have the table made, we need to circle any findings in our chart and write ourselves little notes. So if the slopes are the same, then we write ourselves a note about congruence. If the lengths are the same, then the segments are congruent. If the slopes are the same, the segments are parallel. If the slopes are opposites, then the segments are perpendicular, meaning that there must be a right angle. So you can see in this example off to the right here that I have, our goal is to prove that it's a rhombus but not a square. So I made the big chart for everything. And then I started circling some stuff. In this table I found 5, 5, 5, 5 for all of my distances. I didn't write the note, but I should have written a note to myself about all 4 of these that they are congruent. So then from here, we write conclusions. We have to start specific, meaning talk about sides. Not take, talk. Whoops. Oh goodness, what am I doing? Apparently I can't erase that. So we're going to say talk about sides. Like AB is congruent to BC is congruent to DA, and then we give a reason, such as because same length. Again, length is with congruent. Slope, that's the same as with parallel, and opposite reciprocal slopes gives you perpendicular. Then once we have the specific conclusions, we go to general ones, meaning a summary of the specific ones. So this is a rhombus because all 4 sides are congruent. Sometimes you're asked to prove not a shape. Just like you see in this example, prove that it's not a square. So you still make the full table, you just have to think about how to prove it is a square and then show that the table doesn't make that work. So I know that a square has 4 congruent sides, but I also know that it has 1 right angle. I got the 4 congruent sides, that's already part of a rhombus, but it does not have 1 right angle, which means I need to show that I don't have perpendicular slopes. So I could have written myself a note that these are not perpendicular. I'm still making conclusions about it and still making that general conclusion at the end, but you just have to look for what doesn't work in comparison to what does work to prove that it is or is not a shape. If you flip it over, we'll get some practice with actually doing problems like this. So the first one just says, given the table below, prove ABCD is a parallelogram. So say we know nothing about parallelograms, that's okay. We just have to look at our slopes and our distances and make some conclusions. This chart will likely not be given to you on an exam. This is just to get us to think about some conclusions we have to make and to save some time. We will be doing a full proof on the next page, just like you'd see on a Common Core exam. So whenever we have slopes, we need to reduce them. So 4 over 2 can be reduced to 2 over 1. If you're not sure how to reduce, it's all about dividing by a number that's in common, or you can simply type it into your TI Inspire, 3 divided by 6 for the next one, and it'll spit back at you 1 over 2. So go ahead and reduce the next 2 slopes. Once we do that, we should be able to see some commonalities here. I see a 2 over 1 and a 2 over 1. This is talking about slopes, so that means that these lines are parallel because they are the same. Then I see a 1 over 2 and a 1 over 2. These, again, same slopes, means that lines are parallel. So I'm going to go ahead and make that conclusion right now. I circled AB and I circled CD. So AB is parallel to CD, and we have another pair. BC is parallel to DA because, well, this is because they had the same slope. So then I'm just going to look back at my slopes to be sure that there's nothing else to conclude. we can conclude that lines are parallel or perpendicular from slopes. Remember, perpendicular lines have opposite reciprocal slopes, so I'm looking and I see a 2 over 1 and a 1 over 2. Opposite reciprocal means flip and negate. I don't see any negations happening here, so we're done with the slope column. When we move on to the distance or length column, we have square root 20, square root 20. Distance or length being equal means that segments are congruent. Same with square root 45, square root 45, again, congruent. So let's make that statement. AB is congruent to, find the one you paired it with, AB paired with CD, and BC is congruent to DA, and the reason is because same length. Now if you want to use the word distance here instead, that's fine, perfectly acceptable. So we have our specific conclusions done, but now we have to move on to the general conclusion. A, B, C, D is a parallelogram, just like they told us, because now we're summarizing what we found out up above. Here in this first bullet, we found sides that are parallel, and more specifically, opposite sides are parallel. And then next, in the second bullet, we found that opposite sides are congruent. So, and congruent. We don't even have to repeat opposite sides because it's already in the statement there. ABCD is a parallelogram because opposite sides are parallel and congruent. We're going to move on to the next one, where we are asked to prove that ABCD is a square. So again, somebody so nice, me, made up this chart so that we could save ourselves some time. On the next example, we're going to make the chart ourselves though. So we have change x, change y. We have this column here, change y over x, which means slope. And then we have Pythagorean theorem, which means length. So again, first step is to reduce all of those slopes. Take that 4 over negative 6 and reduce it. This gives you negative 2 over 3. Go ahead and reduce the next 3 slopes, please. So I'm going to start circling noticing some similarities on my table. First I see a negative 2/3 and a negative 2/3. That tells me, because they have the same slope, that these lines are parallel. Then I see a 3 over 2 and a 3 over 2. Again, same slope, parallel. So let's make that conclusion. AB is parallel to CD. And see if you can fill in the next part. BC is parallel to DA because, go ahead and fill this in yourself. You should have said because same slope. Now, again, we need to look back at the slope column to see if there's anything more that we can conclude. If there's not, that's fine, but we need to check it to be sure. I see this negative 2/3 and then I see a positive 3 over 2. Those fractions looked like they're flipped upside down and negated, which means that they are oprecips, so those lines must be perpendicular. So we're going to make that conclusion. AB is perpendicular to BC because instead of same slope this time, they were oprecips. Now there is a little bit of an extension we have to do with this one. After we say oprecip slopes, we have to say so angle B is a right angle. And maybe you're wondering why I chose B, and the reason is because when I say segment AB and BC, B is the letter that gets repeated because that's the shared vertex, meaning that that's where the right angle is. So we're done with the slope column. We're going to move on to the length column. I see square root 52, square root 52, square root 52, and wow, square root 52. So the note that I'm going to write here is that they're congruent. Remember, length gives us congruence. So this is a big long chain that we're going to write. AB is congruent to BC, is congruent to CD, is congruent to DA, because same length. Again, if you want to use the word distance here, that's fine, but you do have to write out same length or same distance. So, we've concluded everything that we can from the table, but now we need that general conclusion. A, B, C, D is a square because, alright, so work from the top to the bottom. The first bullet we said we have pairs of parallel sides. So our reason, first one, would be because sides, meaning opposite sides, are parallel. Then, in the blue bullet, we said that we have perpendicular lines. And that gave us a right angle. So we have, because opposite sides are parallel, there is a right angle. And in the purple bullet, we have 4 congruent lengths. So we're going to say, and 4 congruent sides. So again, the last statement is very generic. It's a summary of what you concluded up above. Opposite sides are parallel. There's a right angle, and we have 4 congruent sides. If you flip it over, we're going to actually do a full proof together. So number 3 is something that you could see on a Common Core exam. This specific question was not on a Common Core exam, but something like it has been. It says that quadrilateral JKLM has those 4 coordinates, and we want to prove that it's a rhombus but not a square. It says the use of the coordinate grid is optional. It's up to you whether you graph it or not. Remember in the last video I said maybe it's a good habit to start plotting everything, just in case you need to use it. I'm not going to spend the time using it today or now, so I'm not going to plot it. However, if you would like to, just pause the video and then jump back in whenever you're done plotting. So to do this proof, we need to make a really big chart with the 4 side lengths, with change x, change y, and Pythagorean theorem. I don't care if you squeeze it up here in the top section or if you just use the bottom section, it's your choice. It is going to spread pretty far across your paper though. So our first label is for sides. Then after that we have change x, change y, Pythagorean theorem, and change y over change x. The first side length that we have would be JK. Next would be KL. Third is LM. And then to wrap it up is MJ. In the last video, I'm not sure if you watched it or not, but I took some time to write the coordinates beneath each letter. So J, for example, is 2, 4. Wow, this is not writing correctly. 2, 4. Then K is at 5, 6. Again, K, 5, 6. And L, 8, 4. L is 8, 4. M is 5, 2. M is 5, 2. And J is 2, 4. The reason I do that is because it makes it easier for us to look for the change in x and the change in y. When we find change, that means to subtract. So first I'm looking at x values. So for JK, for instance, that means I take my 2 and my 5 and I subtract them. They're stacked right on top of one another, so it just makes it easier on your eyes to figure out how to find the change. 2 minus 5, which is negative 3. Then change y, we have 4 minus 6, which is -2. Find all of your changes first, meaning the first two columns, and then I want you to pause the video while you do that. I'll do the same up here for mine. I'm going to find all the changes. When you are done, play the video again so that you can check your answers with mine before we move on. Okay, so I found my changes. I showed my work. Now these values become A and B. Check your answers with mine before we move on. If you need to pause the video, that's fine. But now we're going to plug them into Pythagorean theorem. When we plug into Pythagorean theorem, you can ignore the negatives. However, when we plug into slope, change y over change x, you cannot ignore the negatives. You have to have them. So we have 3 squared plus 2 squared equals c squared. Go ahead and type in 3 squared plus 2 squared in your calculator. You should get 13 equals c squared. Now in order to get c by itself, we square root both sides. So final answer here, we have c equals square root 13. Go ahead and follow that process again all the way through the bottom. Pause the video if you need to. I'm going to, put all my answers up here. When you're done, hit play so that you can check your answers with mine before we move on to the last column. Again, you can ignore the negatives for this Pythagorean theorem column. Okay, so I found square root of 13 for all of my answers for Pythagorean theorem. Now for the last column, we're still going to use these two values, change y and change x, but we're going to put change y on top of change x as a fraction. So for the first one, for example, we have -2 over -3. The double negative reduces to become a positive, so final answer here should be 2/3. Anything that can be reduced, you should reduce. Otherwise, just leave it the way that it is. Go ahead and fill in the next 3. Pause the video while you do it. Check your answers when you're done. Okay, so we're going to start looking for some things that we can conclude here. I see that I have square root 13, square root 13, square root 13, square root 13. So let's make a conclusion about all of those. We have JK, which is congruent to KL, congruent to LM, congruent to MJ. Notice I chose the congruent symbol, not parallel, not perpendicular, but congruent, because we're talking about same length. Okay, let's make another conclusion. If we look at our slopes, I see a 2/3 and a 2/3, a -2/3 and a -2/3. So here I can pair these off and tell myself that these are parallel. So next bullet, we have JK, which is parallel to LM, and KL is parallel to MJ, because same slope. So I just want to go back up and read our goal here. It says prove that JKLM is a rhombus but not a square. So when we see our basic properties, or when we think about our basic properties of a rhombus has 4 congruent sides. And you're probably like, well, wait a second, so does a square. And yes, you're right. A square has 4 congruent sides. But there's something special about a square that a rhombus doesn't have, and that's one right angle, or at least one. We know that there's 4. Right angles, remember, come from perpendicular lines, and perpendicular lines come from opposite reciprocal slopes. If we look at our slopes here, say the first two, JK and KL, I have a 2/3 and a -2/3. Opposite reciprocal, again, means flipped and negated. Not just negated, not just flipped, but two of them together. 2/3 and negative 2/3 are not flipped, which means that these are not perpendicular, which means that we can write a conclusion here about JK being not perpendicular to KL because not opposite slopes. So, angle K is not a right angle. From here, we make our final and general conclusion. JKLM is a rhombus, but not a square, because now we conclude what we summarize what we concluded up above. So to summarize that first bullet, we can say because there are 4 congruent sides. To summarize the second bullet, we can say opposite sides are parallel. And to summarize the third one, we can say but there is no right angle. Lots of writing, lots of work, but these are typically worth 4 to 6 points on an exam. So be prepared to, have your assessment on this. Get some practice on the next couple of pages. Some of the problems the table's given to you, other times it's not. Do everything that you can, to help yourself be successful. So if that means rewinding, pausing, whatever it happens to be, help yourself be successful. Ask questions to the teacher around you and move on to your practice. Good luck.